We are going to see about medium access control. So medium access control is important issue in network technology, which means it rules through which devices can transfer data among them in a network. That is, when a device is connected to a network, it obtains an unique MAC address, and it identifies a device connected to the network. And the MAC addresses are also known as hardware address. So let us see about the medium access control in detail in this video. So here we are going to see about what random access technique, what are the random access technique is used, what is Aloha and CSMA bar CD and CSMA bar CA, and what are the controlled access, that is reservation, polling and token passing, and what are the channelization, that is FDMA, TDMA and CDMA. And the medium access control is a sublayer of the data link layer. The MAC sublayer evaluates the full duplex logical communication channel in the multi-point network, and this channel may also provide a unicast, multicast and broadcast communication services. So the MAC sublayer uses a MAC protocol to ensure that the signal is sent from different stations across the same channel and does not collide. That is, two people can speak at a time. And the medium access protocol to coordinate the access to the link. It can be a multi-point or a broadcast link. So many protocols have been devised to handle the shared link. Next, let us see about the taxonomy of multiple access protocol. So it has some random access protocols, controlled access protocols and channel protocols. So in your random access protocol, you will see about what are the techniques, Aloha, CSMA, and the carrier sense multiple access with the collision detection, and carrier sense multiple access with collision avoidance, and control access protocol, which is something that reservation, polling and token passing, and channelization protocol is FDMA, TDMA and CDMA. And let us see about this in detail. So let us see the random access. So this is also said to be a content based access, that is, no station is superior to another station, and also no station is assigned to control another station. So any station can act as a master at any time. Okay, and a station that has data to send uses a procedure defined by the protocol to make decision or whether or not to send, or not to send. Okay, and decision depends upon the state of medium, that is, it is ideal or busy. And the two main features of random access is this: it has no scheduled time for a station to transmit, and it has no rules specified which the station should send next. So the station is completely with one and another to access the medium. This is the basic thing of random access, and that is said to be a contention based access. And next is your Aloha. Aloha is a type of random access protocol. It was developed in University of Hawaii in the early years 1970, and it was designed mainly for radio, that is wireless LAN, but it can be used in any shared medium. And there are two types of, one is your pure Aloha, another one is a slotted Aloha. There is a potential of collision compared with the other techniques. The medium is shared between the station, and the station sends data, and the station may be attempt to do at the same time, and the data from two stations collide and become scrambled. So one is your pure Aloha. This is something said to be your Aloha protocol, and this is a simple but elegant protocol. The idea of each station sends a frame where it has a frame to send. Okay, that is multiple access. However, since there is one channel to share, and there is a possibility of collision between the frames from different station. Next, this is an example of transmitting a frame from one station to another station in a pure Aloha. Next is slotted Aloha. So the slotted Aloha divides the time of shared channel into a discrete interval called time slot. So any station can transmit its data in any time slot. The only condition is that the station must start its transition from beginning of time slot, and in the beginning of the time slot is missed, the station has to wait until the beginning of next time slot. So the collision may occur if one or more stations try to transmit the data at the beginning of the same time slot. So the slotted Aloha was invented to improve the efficiency of pure Aloha. So this is an example of slotted aloha. Okay, so in this you can see how the efficiency is improved. So next is your CSMA. CSMA is something that carries sense multiple axes. It is mainly used to minimize the chance of collision and to increase the performance. So it is sense before the transmit, listen before the talk. That is, carrier busy is represent here, transmission is taking place, and carrier idle is something that there is no transmission currently taking place. So here in your CSMA can reduce the possibility of collision, but it cannot eliminate it. Next is your carrier sense multiple axis with collision avoidance. So collision detections. So it's something that a station monitors a channel while sending a frame. If however there is a collision, the frame is sent again. Example, collision of the first bit is in CSMA bar CD. Station A and C are involved in collision. Next is your carrier sense multiple axis with collision avoidance. So here the carrier sense multiple axis with collision avoidance was invented by wireless network, and it is used in a network where collision cannot be detected. So here the collisions are avoided through the use of CSMA bar CA in three categories. That is your interframe space, contention window, and acknowledgement. So this diagram represents how the data have been transferred from one end to another. So here the interframe space where an ideal channel is found, the station does not send immediately, and it waits for a period of time, so that it is called interframe space, that is said to be IFS. Next is your contention window. Contention window is an amount of time divided into slots. So if a station determines that the channel is free, they wait for a random amount of time before they start sending. So this time of window doubles each collision corresponding to the binary exponential back off. Okay, next is your acknowledgement. The positive acknowledgement and the timer can help the guarantee that the receiver has received the frame. And hope you all understand what are the random access control. And if you have any grievance, any doubts related to this topic, feel free to approach me. Thank you, students.